So now that we've looked at systems using quadratic equations as well as linear equations, we're going to look at systems of linear equations in 3 variables. And the first thing we have to do is define a new term. And that new term is an ordered triple. Okay? Up until now, we've only been working with ordered pairs. An ordered pair is a point 1, 3 on the Cartesian plane. Okay, whereas now we've got an ordered triple, which has 3 items in the parentheses. So we've got x, y, and z. And this is a solution to a linear equation in 3 variables as seen by the formula here. A times x plus b times y plus cz is equal to d, where all 4 of those variables, so a, b, c, and d, are real numbers. Okay, so we're only looking at real numbers still. This is called a linear equation, and we, up until now have always assumed linear means line. But the graphs of these equations are actually not lines, they're planes, and that's because we are in the 3 dimensions now. Okay, so instead of a line being the basic graph in 3 dimensions, it's a plane. Okay, and that's all a lot of fancy talk, but essentially that just means all of our solutions are going to be with 3 variables. All of our equations are going to have 3 variables. So if you ever end up with only 2 variables in your equation, that means that the third one has a constant of 0. Okay, so let's look at some examples. In number 4, we're given 3 equations. The first one says 5x minus 3y plus 4z is equal to 4. The second one says 4y minus 3z is equal to 10. And the third one says 3z equals negative 6. Now, if you've noticed, I've drawn a dotted triangle around this. This is because this is what's called a triangular system. And we're going to use triangular systems to solve all of these linear equation systems, okay? Mostly because it's neat and it's tidy and it's pretty much one of the simplest ways to do this. So first thing we have to note is that if you see here in this last equation, we've only got one variable equal to a number. That means we can solve for z automatically. So if we were to divide both sides by 3 in that last equation, we'd get that z is equal to negative 2. And then if you look at the second equation, we've got z and y. So if we plug in negative 2 for z, we should be able to solve for y. So then we get that 4 times y minus 3 times negative 2 is equal to 10. 4y is equal to 10 minus 6, which is 4, so y is equal to 1. Now that we have z and y, we can solve for x using the first equation because it's got x, y, and z. So we plug in, we get 5x minus 3 times 1, which we plug in for y, plus 4 times negative 2 equals 4. 5x minus 3 minus 8 is equal to 4. So 5x is equal to 15, x is equal to 3. So we've got x, y, and z. So we're going to write this as the solution, x first, so that's 3, y second, 1, and z last, negative 2. And that's our answer. In that first example, the way to find the solution was very simple. Unfortunately, most of them are not like that. So if we move on and look at number 12, the 3 equations we're given are 2x minus y equals 3z minus 3, 3x plus 2y equals z minus 1, and x plus 3y is equal to z minus 10. Okay, so we've got 3 equations, all with 3 variables in each, and we need to solve. So the first thing I'm going to do is I'm going to reorganize this, which you can do. And I'm going to put this last equation here first. I'm going to move this first one down and the last one down. So then my new order is going to be x plus 3y equals, and I'm going to move z over while I'm at it, minus c is equal to negative 10, 2x minus y minus 3z is equal to negative 3, and 3x plus 2y minus c is equal to negative 1. And if you're wondering why I moved it the way I did, is because if you notice in this first equation now, the x is a constant of 1, and I'm going to use this to solve for x at the very end, and so I want to make it easy for myself as we move along. Additionally, when we're doing triangular systems, we usually want to transform the first to cancel out terms in the second and third, especially the x, and so if this is 1, it makes the transforming it a little easier. Okay, so what I'm going to do is I'm going to draw a little box around it, and I'm going to do all the work on the right side of that line, the vertical line that I drew. So first thing I'm going to do is I'm going to transform the first equation by multiplying by -2. So I get -2x minus 6y plus 2z is equal to 20. And I'm going to then set the second equation underneath it, and I'm going to cancel out the y's. The x's. So the x's cancel, and I'm left with -7y minus c is equal to 17. Okay, and so that's going to replace my second equation now. So I'm going to write that underneath. So we copy my first, because we're not going to change that one at all, and I'm going to copy my second. And then I need to transform the third as well. So I'm going to then multiply the first equation by a -3. So this time I get -3x minus 9y plus 3z is equal to 30. And I'm going to copy my third equation underneath that, and then I'm going to solve. So I get -7y plus 2z is equal to 29, and that's going to now replace my third equation. So -7y plus 2z is equal to 29. Okay. Now to solve, I really need to get this last equation here to have only one variable like we did in example 4. So what I'm going to do is I'm going to transform the second equation by multiplying it by a negative, and then I'm going to solve the system between the second and third equation here. So I get 7y plus c equals -17 when I multiply all of it by a negative. And then I copy my third equation underneath, and I get that 3z is equal to 12. Okay, so then when I replace this third equation, I get x plus 3y minus c is equal to -10. -7y minus 3 is equal, z, can't even read my own writing today, is equal to 17, and 3z is equal to 12. If you notice, now I've got it in the triangular system similar to how we had in example 4. So now I can solve. I'm going to first solve for z by dividing both sides by 3. Then I'm going to plug that into my second equation. So I get that y is equal to -3. And then I'm going to plug z and y into my first equation. So x minus 9 minus 4 is equal to -10. X is equal to 3. So I've got 3 for x, -3 for y, and 4 for z. So my solution is 3, -3, 4. Let's look at another one. For 14, we're going to solve the three equations as you see on the screen. So we've got 2x plus 2y plus z equals 3, 3x plus 2y minus 2z equals -1, 5x minus 2y minus 6z is equal to 17. Now up until now, we've always been solving essentially to get it into a triangular form where z is the first variable that we solve for. In 14, it's actually going to be simpler to get rid of to solve for x first instead. And that's because if you notice here at the last term, this z is has a constant of 1. And so it's going to be easier to cancel out the z's in the first round. So what we're going to do is we're going to transform this first equation by multiplying it by 2. And then we're going to solve the system of equations between the first equation and the second one. So I'm going to copy the second one underneath that. And the z's cancel out, so I'm left with 7x plus 6y is equal to 5. So this is my new second equation. And then I'm going to transform the first equation by multiplying it by 6. And solve the system of equations between the first equation and the third one. So the z's again cancel out. I'm left with 17x plus 10y equals 35. This is my new third equation. So I'm going to copy each of those in. So I copy my first from the beginning, because I'm not going to change that one. Copy my new second, so that's 7x plus 6y equals 5. and copy my new third. So that's 17x plus 10y is equal to 35. Next, I want to get rid of the y in the last equation, so I'm going to multiply the second equation by negative 5. So that's negative 35x minus 30y is equal to negative 25. And then I'm going to multiply the third equation by 3. So I get 51x plus 30y is equal to 105. My y's now cancel out, and I'm left with 16x equals 80. This is my new third equation. So I'm going to then plug that in. So I get 2x plus 2y plus z equals 3. 7x plus 6y equals 5. And 16x equals 80. I now have the triangular system that I desire, right? So I'm going to solve for x first in that third equation. So I'm going to divide both sides by 16, and I get x is equal to 5. I'm going to then plug that into my second equation. So I get 35 plus 6y is equal to 5. 6y is equal to negative 30. Y is equal to negative 5. And then I'm going to plug in x and y into my first equation to solve for z. So I get 10 minus 10 plus z is equal to 3. The 10s cancel out, so I get z is equal to 3. So my solution is 5, negative 5, 3. Okay, now let's look at 18. 18 says 1 over r plus 3 over s minus 2 over t is equal to 1. 2 over r plus 3 over s minus 4 over t is equal to 1. And 1 over r minus 6 over s minus 6 over t is equal to 0. Now, if you remember from our work that we did at the beginning of last year, so this is right around first quarter, we replaced r, s, and t with new variables so that we wouldn't have to deal with the fractions. So we're going to do that again. So first thing we're going to say is let 1 over r equal x, 1 over s equal y, and 1 over t equals z. Okay, and so then we're going to plug all of those in. So we end up now with our systems looking like x plus 3y minus 2z is equal to 1, 2x plus 3y minus 4z is equal to 1, and x minus 6y minus 6z is equal to 0. And so we're going to attempt to solve this again. So the first thing I'm going to do is I'm going to transform my first equation and solve a system of equations between the first and the second. So I'm going to multiply the first one by negative 2. So I get negative 2x minus 6y plus 4z is equal to negative 2. 2x plus 3y minus 4z is equal to 1. The 2x's cancel, and so do the z's. So I'm left with negative 3y equals negative 1. This is a nice turn for us because that means we only have to do one more transformation and we can be able to solve. So then I'm going to transform my first equation by multiplying it by negative 1. So I get negative x minus 3y plus 2z is equal to negative 1, and solve that with the third one. So x minus 6y minus 6z is equal to 0. So the x's cancel out, and I'm left with negative 9y minus 4z is equal to negative 1. This equation that we just did is going to be my new second, and the first one we did was going to be my new third, so we can get that triangular shape again. So I'm going to copy my first, x plus 3y minus 2z is equal to 1. Copy my second, negative 9y minus 4z is equal to negative 1. And copy my third. So negative 3y is equal to negative 1. Now that I only have one variable left in my third equation, I'm going to solve for y by dividing everything by negative 3. So I end up with y equals 1/3. So then I'm going to plug that into my second equation. So I get negative 3 minus 4z is equal to negative 1. So negative 4z is equal to 2. Z is equal to negative 1/2. Then I'll plug in my y and my z into my first equation. So x plus 1 plus 1 is equal to 1. So x plus 2 is equal to 1. X is equal to negative 1. We're not done though. Remember that at the beginning we changed all of our variables, as you see at the very top. So we have to plug in and solve for r, s, and t accordingly. So first thing we're going to do is rewrite. So x is equal to 1 over r, y is equal to 1 over s, and t is equal to 1 over z. Sorry, z is equal to 1 over t. Whoops. So I'm going to plug in x and solve for r. So negative 1 is equal to 1 over r. So negative r is equal to 1, which means that r is equal to negative 1. For y, I'm going to plug in y and then solve for s. So I get 1/3 is equal to 1 over s. So s is equal to 3. And then lastly, for z, I'm going to plug in negative 1/2. That has to be equal to 1 over t. So that means that t is equal to negative 2. So my solution is negative 1, 3, negative 2. So let's look at some word problems with linear equations of 3 variables. Number 2 says David paid $9.50 for some 15-cent stamps, 25-cent stamps, and 45-cent stamps. He bought 38 stamps in all. The number of 25-cent stamps was 8 more than twice the number of 45-cent stamps. How many stamps of each type did David buy? So first thing we have to notice is that they give us 3 separate equations. The first one is that the stamps add up to a value of $9.50. So we're going to name the 15-cent stamps X, the 25-cent stamps Y, and the 45-cent stamps Z. So if we multiply each number of stamps by their total value, that has to be equal to 950, right? Because that's what it says for the dollar amount. Then it says that he bought 38 stamps in all. So that means that the total number of stamps adds up to 38. And then the last one says the number of 25-cent stamps was 8 more than twice the number of 45-cent stamps. So that means that the Y stamps has to be equal to 8 plus 2Z, right? Because it's 8 more than twice the number of Z. And so then we have our 3 equations. So before we start solving, we need to get the z in the third equation onto the left side of the equal sign, as well as dividing the first equation by 5 to get rid of the large numbers. So we end up with 3x plus 5y plus 9z is equal to 190. Then we copy our second equation because we're not going to change that. And then we subtract 2z from both sides for the third equation. Okay? So first thing we're going to do is we need to get rid of that x in the second equation. So we're going to transform it by multiplying it by a negative 3. So we get negative 3x minus 3y minus 3z is equal to, which is negative 114. The x's cancel out. I'm left with 2y plus 6z is equal to 6, 7, 0. So 76. Okay. Before I put that back in though, I'm going to divide it by 2 so that I can get a smaller number. So this ends up being 38. Right? So I have 3x plus 5y plus 9z is equal to 190, and y plus 3z is equal to 38, and y minus 2z is equal to 8. I want to solve for z first, so I'm going to cancel out the y's for the third equation. So I'm going to multiply the third equation by a negative 1. So I get negative y minus 2z is equal to negative 8. And my y's cancel. I'm left with z equals 30. 5z equals 30. My bad. So now that I have my equations, let me rewrite them one more time. We get 3x plus 5y plus 9z is equal to 190, y plus 3z is equal to 38, and 5z is equal to 30. So now we can solve for z, which when we divide by 5 is 6, We're going to plug that into our second equation, so y plus 18 is equal to 38, so y is equal to 20. And then we're going to plug in both y and z into the first equation, so we get that 3x plus 100 plus 54 is equal to 190, so 3x is equal to 36, so x is equal to 12. So that means we have 12 15-cent stamps, 20 25-cent stamps, and 6 45-cent stamps. Okay, for number 4. It says a chemist has 3 samples of unknown mass. Each pair of samples is balanced against the third sample and one of 3 known masses. Find the unknown masses if the known ones are 9g, 15g, and 27 grams. So we're going to name the 3 samples X, Y, and Z. All right, and it says that each pair of samples is balanced against the third sample. So hopefully from chemistry you know that by balancing we mean we're adding them together, yes? So that means that X plus Y has to be equal to Z, well, let's say plus 9, okay? And then Y plus Z has to be equal to X plus 15, and X plus Z has to be equal to Y plus 27, just to name a few. And so before we start solving, we're going to get all of the variables on the left and keep the numbers on the right. So this becomes X plus Y minus Z is equal to 9. Negative X plus Y plus Z is equal to 15. And X minus Y plus Z is equal to 27. And so to solve this, I am going to add the first and second equations together. And my x's cancel out, and so do my z's, so I'm left with 2y equals 24. And then I'm going to add my third and my first together. So I get x plus y minus z equals 9, x minus y plus z equals 27. So my y and my z cancel out this time, and I'm left with 2x equals 36. And so when I plug those back in, I get x plus y minus z equals 9, 2y equals 24, and oh my god, my pen won't write tonight, 2x is equal to 36. So I can solve for x and y. If I divide x by 2x by 2, I get x equals 18. If I divide 2y by 2, I get y is equal to 12. And so I'm going to plug 18 and 12 into my first. 18 plus 12 minus c is equal to 9. 30 minus c is equal to 9. So negative z is equal to negative 21. C is equal to 21. So my 3 unknown masses are 18 grams, 12 grams, and 21 grams. All right, so I broke up these videos because I wanted to try and give you a little bit of a breather as we're going through these, because the word problems do get long and tedious. So I will see you in part 2.